A very good evening to our Director, Brother Jose Turutil, Principal Dr. Sunsi George, Dr. Gautam Shah, HOD EXTC Department, Dr. Kevin Narona, Dean Academics, and all our registered participants. St. Francis Institute of Technology is honored to have your virtual presence for the webinar on libraries and tools for machine learning by Mr. Santosh Chapaneri. At SFIT, we have a tradition to begin all our events with our college prayer. Let us all take a few minutes to join in prayer for our world to heal and come together in these difficult times.
Make me a channel of your peace. Where there is hatred, let me bring your love. Where there is injury, your pardon, Lord. And where there's doubt, true faith in you. Make me a channel of your peace. Where there's despair in life, let me bring hope. Where there is darkness, only light. And where there's sadness, ever joy. Oh, Master, grant that I may never see so much to be consoled as to console, to be understood as to understand, to be loved as to love with all my soul. Make me a channel of your peace. It is in pardoning that we are pardoned, in giving of ourselves that we receive, and in dying that we learn to eternal life. Oh, Master, grant that I may never see so much to be consoled as to console, to be understood as to understand, to be loved as to love with all my soul. Make me a channel of your peace. Where there is hatred, let me bring your love. Where there is injury, your pardon, Lord. And where there's doubt, true faith in you.
Thank you, sir. There is an old saying, you sleep peacefully in your beds at night because there are people who stay awake, guarding the borders and keeping you and the whole country safe. Every soldier standing at the border, guarding the sky and the sea, has a life which they cherish, just like you and me. They are like a family you never met, but always have. Soldiers don't get killed, they get martyred. For me, for you, for the nation. As a mark of our respect to the sacrifice of our Jawans, we request you to kindly observe a minute of silence to pay homage to the martyred soldiers. Thank you. I now invite Dr. Kevin Naronna, Dean of Academics, SFIT, to present the welcome address.
Good evening, ladies and gentlemen. I, Dr. Kevin Naronna, on behalf of Department of Electronics and Telecommunication Engineering and St.Francis Institute of Technology, extend a very warm welcome to all the participants who have joined from across the country. To begin with, let me introduce to all of you about St. Francis Institute of Technology because you have joined from all across country. St. Francis Institute of Technology, which is known as SFIT, was established in the year 1999 in the midst of a generous 5 acres of lush verdant settings in order to provide a conducive environment to the young engineering aspirant, thus fulfilling the long felt public need of an institute of excellence in the field of engineering in Mumbai. SFIT is approved by AICTE and is permanently affiliated to University of Mumbai. It is a private, unaided, self-financing, religious minority educational institute. Currently, SFIT offers 5 undergraduate programs in the most coveted disciplines such as computer engineering, electronics and telecommunication engineering, information technology, electrical engineering, and mechanical engineering, and postgraduate program as well as PhD in technology in computer engineering and electronics and telecommunication engineering. National Board of Accreditation (NBA) has granted accreditation to 2 UG programs, that is Electronics and Telecommunication Engineering and Information Technology, for 3 years, that is till June 2022. Additionally, the institute is also certified meeting the quality management system standards ISO 9001:2015 for providing undergraduate courses in engineering and technology. I'm also honored to mention that SFIT has been consistently ranked one among the top 5 engineering colleges under the University of Mumbai. Its campus placement too is very impressive that above 90% of eligible candidates are placed. Now coming to the Department of EXTC, which is hosting this particular webinar, the EXTC department has the following faculty, that is professors. We have 4 professors, 2 associate professors, and 17 assistant professors. 5 of the faculty members have completed PhD, and 4 faculty members are pursuing PhD. To enhance the quality of teaching, we sponsor the faculty for higher studies. We also organize and sponsor our faculty for quality improvement programs, for short-term training programs. Also, we conduct faculty induction and development programs. The research and development activities of the department ranging from faculty publication in peer-reviewed journals, lectures and webinar series. You can see one of the webinar series today. Departmental project, minor research grant projects, and recently EXTC department has got a MODREP grant of 7 lakhs from AICTE. These are the few companies who visit regularly to SFIT. To name a few, we have Tata Consultancy Services, Capgemini, Accenture, Reliance Jio, L&T Infotech, Tech Mahindra, and so on. Our students from the department have excelled in technical as well as non-technical activities. In the last year, Robocon team of SFIT won a design competition organized by Dassault System. In this COVID-19 scenario, 2 of our students have developed equipments which will be useful for the public at large. Mr. Trilok Sawant has developed a portable ventilator, and Mr. Aditya, who has developed a UV disinfectant robot. Lastly, this is our department photograph. You can see Dr. Gautam Shah head of the department at the left-hand side with the management people and the department staff. With this, with this introduction about the department and the college, I would like to invite all of you for this webinar. First of all, I would like to welcome Brother Jose Turitil, Director SFIT, Dr. Cincy George, Principal SFIT, Dr. Gautam Shah, Head of the Department EXTC, all the deans and HODs and faculty members of SFIT. My dear participants, you have joined this webinar from across the country. On behalf of SFIT management and EXTC department in particular, I would extend a very heartily welcome to all the participants. Last but not the least, today's resource person, Dr. Santosh Chapaneri. Sir, I welcome you on behalf of our department and wish all the participants a very happy webinar. Okay. Thank you.
Thank you, sir. Today's webinar on machine learning will be conducted by Mr. Santosh Chapaneri. Mr. Santosh Chapaneri has completed his MS in ECE from the University of Arizona, USA, and BE in EXTC from the University of Mumbai, India. He has an experience of 19 years working in industry as well as in academia. His research areas include machine learning and signal processing. He has published 44 papers in reputed journals and conferences and received over 140 citations to date. He is a reviewer of IET transactions on image processing, IET electronics letters, IET communications, IET signal processing, IEEE Access Journal, and various conferences such as IEEE Indicon and ISMIR. He has delivered several offline and online workshops related to machine learning at various meetups in industry and academia, including the NITs. He was an invited speaker for the Machine Learning IEEE India Council. He also gave an invited talk at the IEEE Bombay Section Signature Conference 2019 on the advances in deep learning. He is a frequent speaker for the IEEE Bombay SCEP lecture series. I now invite Santosh sir to begin with today's session. We request the participants to note down their questions in the YouTube chat box. The chat box will be enabled at 5:30 p.m. We will address all your questions at the end of today's session. Thank you.
Thank you very much for the warm introduction. Good evening, all. Today our topic is on libraries and tools for machine learning. So we'll be discussing about some applications and use cases. A simple block diagram here to illustrate the pipeline of machine learning. So there are two halves over here, the top half and the bottom half. So the top half is called the training phase of the machine learning algorithm, and the bottom half is the testing phase. So what happens in the training phase is that you have some labeled data. If we have labeled data, then we will call it as a supervised machine learning. And if the labels are not present and only the data is there, then we call it as unsupervised machine learning. So
Santosh
in
sir,
yes,
I'm
please.
sorry to interrupt you, but could you go to the previous slide? We had some issues, so we were not getting audio on YouTube. So could you just go, yeah, could you just start from here again?
Sure, I will repeat from here.
Thank
So
you.
yeah, I discussed about AI as a bigger set, of which machine learning is a subset. Machine learning is a subset of AI, and deep learning is further a subset of ML. It is more specialized, mainly catering towards neural networks architectures. So data science, data analysis uses these concepts of machine learning and deep learning. So in this webinar, our goal is to see how to develop this algorithms of ML and DL. What are the various libraries and tools available out there that we can use? Here in this slide, so I explained the general pipeline for any machine learning algorithm. There are two halves over here, the training phase and the testing phase. So in the training phase, what we see is we have some label data at the top half. So the label data could be either text or audio or video or image. It could be any type of data. And from the data, several features are extracted. So that concept is known as feature extraction. So once we have the features and the corresponding labels, then we train some machine learning algorithm. So once the algorithm is trained, then in the bottom half, we have the test phase. So in the test phase, again, we have some data on the bottom left. So again, we do some feature extraction, similar technique as what we did during training. And then we expect the learned model to do some prediction on the label. So with these predictions, then we expect the algorithm, we expect that the algorithm should perform better because of the good training. Now we discuss about how machine learning and deep learning are different. What is the difference between ML and DL? So in machine learning, what we have is the handcrafted features. So the top half shows the handcrafted features. So given some input data, we have to manually extract some features. So that is known as the handcrafted features. And then we do the supervised learning, like for example, classification, regression. So that's where the learning takes place. However, in deep learning, we do not extract the features on our own. Rather, we ask the algorithm itself to learn the features from the data. So that's the main keyword here. In deep learning, the features are learned. In machine learning, the features are extracted by us, by humans, and the patterns between the features and labels are learned by the machine. Whereas in deep learning, both features and patterns are learned by the algorithm. So that is the key differentiator between machine learning and deep learning. We'll quickly have a look at some of the use cases where these concepts have been applied in the industry as well as in academia. The first we present is this concept called Detectron, which is the outcome of Facebook AI research. So in Detectron, we can see that this falls under the domain of computer vision, and there is the output, the image is neatly segmented, and for each object that it is able to segment, the algorithm also presents some probabilities. So this falls under the probabilistic machine learning approach. The next use case is by Microsoft, where they have done face detection and emotion classification. So here, what they're doing is, again, this falls under the domain of computer vision, where they not only detect the face, where is the face present, but simultaneously solve the emotion recognition problem. So what is the emotion being shown by this particular face that has been detected? So the output is usually in the form of a JSON file, which can be used for further applications. Right, and then the third use case is, so there's this company called Calorie Mama, which is has the expertise of food and calorie recognition. So given a plate of food items, so there is the API which will automatically detect what is the food item on your plate and how much calories are you going to consume by eating this particular food item. And on the right hand side, you will see the green bar. So the higher the green bar means the higher the probability of that particular item. And the lower the green bar means the probability is less. So the next one is the pedestrian detection. Google is actively leading research for this particular topic. We know that there is a lot of research going on for self-driving autonomous cars. So we can see in this images here that certain images, the people are automatically detected. So that will help the self-driving cars to navigate through the road. Again, this is a computer vision domain problem. Throughout all this, there is a lot of work on computer vision, but a new form of architecture called GAN was developed in 2014. GAN is a generative adversarial networks. The images that you see here are all generated by the algorithm. None of these images are real. They seem to be real, but none of the images are real. They are in fact generated by the algorithm. So that's how good GAN techniques are. There has been a lot of progress as far as GANs are concerned. So for example, here we see something known as cycle GAN. So in cycle GAN, we can see that image translation is feasible with GAN. For example, zebra converted to horse, horse converted to zebra, summer to winter, and so on. So this and there are at least hundreds of variations of GAN architectures, and this technique has made a tremendous progress over the last 2-3 years. The next use case is from the field of NLP. So this is for natural language processing, where given an input image, the output is a caption, which is automatically generated by the algorithm. And we can see that the human caption and the algorithm caption is very much matching. So that's a very good performance. So this is a blend of computer vision and NLP use case. The next recently emerging research area is this neural style transfer. So in neural style transfer, what we see here is there is one image to the left, one image in the middle. So what we want to do is convert the Mona Lisa image to the style in the middle, so that that image is on the right hand side. So we are doing the style transfer over here. Again, there has been a lot of research going on in how to improve the style and how to measure the quality of the image which has been generated on the right side. I, along with some of my students, we also worked, contributed towards some use cases. So in 2018, we did a project on cover song identification. So what we have here is, so on the bottom side, I'm showing you 4 examples of cover songs. So cover song is basically somebody else's performing an original song in his or her own version. So given a particular song, we want to identify whether the song is an original song or a cover song. So for that, we use the concept of convolutional neural networks by taking the audio spectrogram, and we did the ranking based on that, and we were able to identify cover songs. Next, we also dig deeper into the use case of medical imaging. So for medical imaging, we try to identify the skin lesions for cancers, right? So whether a particular skin image has a cancer or not, if it is cancerous, what type of cancer it is. Again, we use the deep learning architectures here to identify the skin lesions. So having looked at this use cases, now I'll discuss some of come to the main topic of tools and libraries. So these are some of the tools. So there's a disclaimer here that I'm not going to cover all the tools and libraries that are available out there. Rather, we'll be looking at some of the more prominent ones. So this is just a glimpse of what are the commonly used tools and libraries available out there. So general purpose tools, we can say there is a scikit-learn API, there is a Weka tool, there is a MATLAB of course, is there. So these are all general purpose applications. For statistical related work, there is software by SAS. There are NumPy, SciPy libraries which are built on top of Python. Then there are some interactive platforms such as a Jupyter notebook environment. In the recent few years, the Jupyter notebook has been gaining a lot of traction because it is very, very easy to use. And because of the notebook environment, all your code, documentation, and your output, everything stays in the same place. So that's why it is much more easier. It's an interactive platform compared to other IDEs. And then there are Orange, there is Tableau. These are all interactive platforms. You can interact with that application. There are some tools related to big data as well. So there is for DL4J, that is deep learning for Java. There is a company called H2O, which is developing a lot of products in that area. And there is also some significant GPU support as well, TensorFlow, PyTorch. So some of this we are going to discuss in detail in the upcoming slides. So now I've divided my presentation for the part into 3 parts. We'll look at the tools, then we'll look at the general purpose libraries, then we'll look at the specific libraries for specific use cases. So let's talk about the various tools that have been developed for machine learning. The first one is by Microsoft, which is Azure machine learning tool. So this one is a highly interactive visual workspace to easily build, test and create a predictive analysis model. This is very, very good for somebody who is not comfortable with writing programs. So ideal for non-programmers. However, the downside is that it is paid, so you need to purchase a license for it in order for you to use that. However, it is very, very interactive, so it should be fun to use that. The second one is developed by Google, which works on the Google Cloud platform. This is a Google Cloud ML engine, which works on GCP. This is really good when you want to train millions of your data points. When you have large scale data, then because of the capability of the Google Cloud servers, this can deployment becomes very easier. And also it uses Hypertune for maximizing the performance. So Hypertune basically means there are a lot of hyperparameters in any machine learning algorithm. So using the Hypertune, the parameters can be automatically created. The next tool is by Amazon Machine Learning. Again, so this one is not like Azure, but this one is pay-per-use model. So you pay only for whatever time you use. But it can integrate data from multiple sources like MySQL, Amazon S3, or from the cloud, and so on. And Amazon ML has lots of inbuilt libraries for face recognition, for sentiment analysis, and so on. So all these 3 tools that I mentioned are paid. So none of the 3 tools by Microsoft, Google, and Amazon are free. They are paid. We'll look at some of the free tools that are available. The first free tool I would like to discuss is known as Orange. This is a very nice tool available for machine learning, very, very good for non-programmers. It is very easy to use. And there are a lot of add-ons available by which you can extend the functionality for what you want to do. You can do data processing, you can do data analysis, you can do the machine learning, you can do data visualization, you can do data evaluation, and so many things can be done by adding the extensions. So this is a very good tool recommended for beginners. The next free tool is Weka. So again, this is a free tool and it supports a wide range of machine learning algorithms. So you can do the usual tasks that we do for machine learning: cleaning, regression, clustering, visualization, and the best part, it is platform independent. So you can seamlessly work on any platform. So I put a screenshot here to show how the Weka software looks like. The next free tool is called Yellow Brick. So Yellow Brick is primarily a data visualization tool. Okay, so it can do visualization across multiple levels of the entire machine learning pipeline. So we can do Once we extract the features, we can visualize those features. It can also facilitate the model selection. For a given problem, we need multiple models to solve. So which is the best model? So that can be done using Yellow Brick. And you can look at the area under the curve for the ROC. And so a lot of visualization techniques are available in Yellow Brick API. So again, this is a nice tool recommended for beginners. Let us look at some of the prominent libraries that have been developed for machine learning. The first one I highlight is based on Python programming language. So this is NumPy, SciPy, and Pandas. So there is a stack of APIs built that you can see on the bottom figure. So on top of Python, there is NumPy, then there is SciPy. NumPy stands for numerical Python, SciPy is scientific Python, and Pandas, and so on. So NumPy is mainly for core numerical computation. So then NumPy is very, very much faster than pure Python. And SciPy is mainly focused on engineering applications. And you have Pandas library, which is very good for manipulating any data. So I'll show you an example usage of NumPy and Pandas here. So I've written a simple Python script to show how it works. So I've imported NumPy Pandas here. I have created a simple variable x, which is ranging from -3 to 3, and there are 20 points. And y is simply cos of x. So I can display y with respect to x using some visualization tool. So the x and y is created using NumPy. And the last 3 lines are the examples of Pandas data frame. So the Pandas, we can read any input data that we have. And there are inbuilt functions available in Pandas to do a lot of meaningful calculations very easily. Like I can do the value counts. I can do the grouping of movie genres together and look at the average duration of each genre. So all that is very easily doable in one line. The next libraries is specifically for visualization. This is Matplotlib and Seaborn libraries. So these are primarily visualization libraries. And so earlier Matplotlib was developed, and then Seaborn was built on top of Matplotlib. There are a lot of data visualization techniques like scatterplot, box plot. You can do the heat map, histogram, bar chart, pie chart, and so many things can be done. And when possible, always use Seaborn because it offers much more functionalities. The next most widely used, most popular machine learning API is, of course, the scikit-learn API, also known as sklearn API. The best part, it is an open source machine learning framework. This is built in Python. It has been shown that it works much faster than R. It has got a great performance. The downside is that it is not ideal for larger data sets. So if a data set is reasonably of a reasonable size, then it should work fine. I put a screenshot here highlighting what are the functionalities provided by scikit-learn. All the algorithms, all the well-known algorithms of classification, regression, clustering, all those are inbuilt in scikit-learn. Here I'm showing you one illustration of how to use the scikit-learn API. Okay, so what I've done is from the 5th line onwards, the first 4 lines are the usual imports that are required from the Python libraries. Then in the 5th line, I've loaded the iris dataset. So iris dataset is the most trivial and the most basic dataset that you would find in machine learning literature. It's a dataset of flowers comprising of 3 classes. So our goal is to, given a new flower, can the algorithm predict what species or what class does this flower belong to? So I have generated X and Y, which are the features and the corresponding labels. Then we've done the train test split because always we saw earlier there is a train and testing. Then I've created a logistic regression algorithm variable. I've fitted it and predicted. So using scikit-learn, it becomes very easy. You can just do it in 3 lines: create, fit, and predict. Okay, so That is how using scikit-learn basic machine learning algorithms can be easily developed. Okay, because all those ultimately all the machine learning algorithms are based on mathematical concepts. So if there is a nice API already available out there which can do all that hard work for you, then it saves a lot of time. Right. The next library here is the TensorFlow, which is developed by Google. Developed and maintained by Google. It is an open source library for machine learning and deep learning. It has been written in Python and C++, and the main advantage is that it maintains something known as data flow graphs. Flow graphs over which the data can easily pass. Usually, the data is in the form of a tensor. Tensor meaning anything which is more than 3 dimensions. Any data having 3 or more dimensions is a tensor. So various tensors flow through this computational graph, hence the name TensorFlow. It has been intentionally designed for a large scale training and inference. And recently, Google updated TensorFlow to version 2. There is also support for TF Lite. So TF Lite is running TensorFlow on mobile and embedded devices. And there is also tf.js, the JavaScript version of TensorFlow, which can be used for deploying our machine learning models in browser. So here is one simple illustration of how to use TensorFlow. So I've imported TensorFlow as TF. I've created a simple TensorFlow variable, initialize it to the value 4. And in TensorFlow, there is this concept called gradient tape. So this gradient tape means it can do the automatic differentiation. So here I have defined y equal to x double asterisk 3, which means y equal to x cube. So if I want to find dy by dx, so if y equal to x cube, then I know that dy by dx is 3x square. But I don't need to write that explicitly. The gradient can be easily found using tape.gradient y by x. So grad is basically our dy by dx. So this is a very simple example, but all this higher order derivatives can be easily computed using TensorFlow. On top of TensorFlow, there is this library called Keras. Okay, again, this is developed and maintained by Google. And it not only supports TensorFlow, it also supports some other libraries like Keano, CNTK, MXNet, and so on. These are some of the popular deep learning libraries that have been developed by many organizations. But Google heavily recommends to use Keras along with TensorFlow because it is very, very efficient in terms of computations. So the advantage is that it enables very fast experiments. It can seamlessly execute over the CPU and GPU. And the advantage is that it contains the latest, the state-of-the-art routines for optimization, for initialization, for the various activation functions. And there is a lot of detailed documentation available on the Keras website. So that is really neat. But however, it is not optimum. If you want to train your own architecture, then you might want to look for something else because Keras provides some pre-trained models as well. So I'm showing you a simple implementation of how to implement a multi-layer perceptron, a simple neural network where I have a simple 3 connections, the input layer having 784 neurons, the hidden layer having 256 neurons, and the output layer having 10 neurons. So that can be easily implemented in Keras using the concept called sequential, where we add layers one after the other. So I have a simple flattened layer, a dense, and then 2 dense layers, so that one dense between input and middle, and another dense between middle and the output. So then we feed this function and we can evaluate the function. So most of this is built on the concept of scikit-learn. And one more example I'll show you here. This is of convolutional neural network, the CNN, which is the deep learning architecture for computer vision. So on the top, I've shown you the architecture that I'm going to implement. I have a convolutional layer of 32 filters. Then MP stands for max pooling layer. Then one more convolutional layer of 64 filters. Then again a max pooling layer. then a dense layer of 128, and finally a dense layer of 10 neurons. So suppose if I have this architecture, then we can see in the implementation that again using the sequential concept of Keras, we can just add all these layers and pass in the appropriate parameters. And again, the last line you will see is the model.fit. So for that, for fitting, again, we can pass our X and Y, and finally we can do the evaluate. So we add the layers one after the other, we compile the model, and then do the fit and evaluation. So that makes the implementation very, very easy. The next library is written in Java, DL4J. This is deep learning for Java. This is the open source distributed deep learning library specifically built for JVM, Java Virtual Machine. If you are looking at distributed training, then DL4J is really very good at that. And one more advantage is that you can implement the algorithms, the well-known algorithms from scratch. If you want to understand the inner workings, then this can help. And it also supports some big data tools as well. However, it is not as popular as Python libraries compared to Python libraries, because the deep learning community, there's a lot of researchers working towards building Python. The next very useful library is PyTorch. So this is developed and maintained by Facebook. So earlier there was a library called Torch, which was written in the Lua language. However, Facebook adopted this Torch and converted it to PyTorch. So they have rewritten all those components using Python. It also supports the CUDA architectures. So using the CUDA architecture, the computations become really, really fast. And it has been used very widely by both scientific as well as industrial communities. The downside is that there's no provision for embedded devices, like for mobile devices. This cannot run on mobile devices, whereas TensorFlow has a nice solution for embedded devices as well. So this was some of the general purpose libraries. We'll now look at some of the specific libraries to cater to certain use cases in machine learning. The first use case I'll talk is about the audio processing, audio, speech, and music signal processing. So here the first library is called Essentia, which is doing a job of audio and music analysis. It can also do synthesis of audio signals. It is written in C++, Python, and it has also recently integrated TensorFlow. And since it is open source, the entire source code is available for you to learn the inner workings of how this processing takes place. We also use this for the cover song identification that we discussed earlier. I'm showing you one snippet of how to use Essentia here. So we pass in the wave file, the name of the audio signal, and then we have a music extractor, which will extract the relevant features. Once we have the relevant features, we can display those features, and we can use any further machine learning algorithm that we intend to use, either it is classification or regression. The next library for this use case is PyAudio Analysis, again catering to audio signals. It can also do a lot of feature extraction, and beyond Essentia, it can also do certain higher level tasks such as audio thumbnailing, like which is the most prominent part of the entire audio signal, that is thumbnailing. It can also do speaker diarization. That means who is speaking when. So if multiple people are speaking in a speech signal, I want to identify who is speaking when, so that can be easily done using PyAudio Analysis. There are inbuilt algorithms available. The next use case is for the computer vision domain. There is this nice library called SimpleCV. So most of us would be familiar with OpenCV, which is written in C++. So Python and OpenCV, they are integrated together, and there is this library called SimpleCV. So this is a nice, so this integrates all the functionalities of OpenCV, bringing it to the Python programming language. So I have shown you some illustration here. Given an image, you can find out the certain key points. Where are the key points? So using hardly 3 to 4 lines of code, this complex task can be easily achieved using SimpleCV. There are many more advanced functionalities in SimpleCV as well. The next use case is for the text processing. For text processing, we all usually talk of NLP, natural language processing. And the two most important open source libraries for NLP are these two, NLTK and Spacey. So NLTK is a natural language toolkit, and Spacey. So both of these are very widely used both by industry as well as academia. I've shown you one simple implementation for doing a tokenization of a string. So for example, I have a str as I love NLP. So how we can do the tokenization using NLTK and how we can do the tokenization using Spacey. So there are inbuilt functionalities already available, which makes this complex task very, very easy. The next library is called Augmenter. Okay, so usually we need to do data augmentation. What is data augmentation means? Suppose I want to use some machine learning or deep learning algorithm, but if my data is of limited size, I have a less number of data samples, so then the learning will not take place effectively. In that case, I can create more examples of my data. I can generate more samples of data using this library called Augmenter. Augmenter, as of now, supports only images, so it can create more samples of images. So I've shown you an implementation here. So there is an Augmenter library. I can create a pipeline of the Augmenter library. Then we can specify how many samples should I want, so that we can do the rotation. By how much rotation? So plus minus 10 degrees. Then how much to zoom? So 1.1x to 1.5x. So I'm specifying the minimum zooming factor and the maximum zooming factor. And then last line is p dot sample 100. So how many such images do I want? So one illustration I have shown at the bottom. So given, for example, a skin tensor image. So from one image, 100 several images can be obtained at different rotations, at different zooming factors, and so on. The next is Julia. This is not a library, but this is actually a programming language. This, we can say, it's a competitor to Python. So Julia is a programming language recently developed in the last couple of years. It is very, very fast, flexible, and very easy to use. So I've shown you the implementation of the same iris dataset using Julia. The concept-wise is the same. There is a slight change in the syntax, but people have been picking up Julia very quickly in the last few years. So I thought I will share this thing with you. The next concept here I would like to share is called LIME. LIME is the abbreviation for Local Interpretable Model Agnostic Explanations. So the thing is that explanations are more important. So whenever we use machine learning or deep learning algorithms, we get some output. Let's say I get a 99% accuracy. But can we explain why did we get this 99% accuracy? Why is this correct and why is something not correct? Why was the algorithm not able to predict something properly? So things like this cannot be addressed by the existing algorithms. So a concept called LIME was developed, where on the left-hand side I have an image, and on the right-hand side, so algorithm is predicting that this is a Labrador, and on the right-hand side, the LIME technique is telling us why does the algorithm think it is a Labrador. So giving explanations to the output of any machine learning model. So I'm showing you an implementation of that LIME library here. So given an input image on the left-hand side, as shown below, I've written some code here called LIME image explainer. And then I want to explain the instance of this particular image, images of 0. So I've done the explanation.get image and mask. So you can see on the bottom image is, sorry, one second. Yeah. So you can see on the bottom image that there are nice boundaries. The cat has nice boundaries that is coming because of the function that I called get image and mask. I guess there is some delay here in the slides. Okay, so the LIME algorithm is able to tell us why the algorithm thinks that this is a cat. So it is highlighted that this is the region I think the cat is present, and that's why I can say with high confidence that this is a cat image. Right. So next, I would like to emphasize on something known as AutoML. So in words of Sundar Pichai, he says that this AutoML was developed by Google, and he says that it is now possible for several hundreds of thousands of developers to design neural networks from scratch for their particular needs using this concept of AutoML. So it's like a machine learning for a machine learning model. Okay, so why is this AutoML important? So for example, again, consider that iris data set that we discussed earlier. So it's a data set of flowers, and there are three classes. So given a new flower, I want to determine it belongs to which class. Now there could be hundreds of machine learning algorithms for doing this task. So how do I know which algorithm is the best for my particular data set? Okay, because as the data set changes, different algorithms tend to perform in a different manner. That is something known as a no free lunch theorem in machine learning. So no one size fits all. So we need to try with the different machine learning algorithms and see which is the best one working for my data set. So AutoML comes into picture over here and says that you just give me the data set, I'll figure out what is the best machine learning algorithm automatically. Okay, so instead of us trying to experiment with different machine learning algorithms, AutoML will do it everything on its own. So there are various libraries for vision, for video intelligence, for NLP tasks, for machine translation. However, all this is paid. So this is developed by Google, but AutoML is not free. Okay, the average cost is around $20 per hour. Microsoft also has its own version of AutoML, Azure AutoML. Again, this can be done on the cloud. It implements this concept called neural architecture search for determining the best algorithm to fit on a particular data set. Again, this is not free. There is a pay-per-use model. So both Google and Microsoft have been trying to get to this AutoML. But since they are not free, but we know that the machine learning and deep learning community is very much into open source. Everything is almost freely available on the net. So then came this concept called AutoKeras. So AutoKeras is making machine learning accessible for anyone and everyone. This is like the killer of Google's AutoML. Because AutoML is not free, it is paid. So AutoKeras is absolutely free. It is open source. You can find the source code on GitHub. And I'm showing you one simple code to illustrate how easy it is to use AutoKeras. I have loaded the data set. I've just specified image classifier, fit, and that's it. So internally, it will find the best possible architecture, best possible algorithm, and give me the ultimate best solution without us trying to experiment with different algorithms. So this will be my concluding slide here. What is the having went through some of the tools and libraries that are available? What is the way ahead? So I have split it into three parts for beginner users, for intermediate users, and advanced users. So maybe you can take a screenshot of this for your reference. So if you are a beginner user, if you are not into programming, then you may want to try the tools such as Orange and Weka because they are very, very interactive and user-friendly. And if you want to venture into programming, then you can start with the libraries like NumPy, Pandas. You can use the scikit-learn machine learning API because a lot of inbuilt algorithms are already available in it. And there is a matplotlib, which is a data visualization library. If you go further, if you are an intermediate user, if you want to progress further, then you can go ahead with the machine learning tools provided by Microsoft, the Azure one, the Google on the GCP, Google Cloud Platform, and also the Yellow Brick for visualization. However, the Azure and GCP are not free. And for programming, you can move ahead with the libraries. You can use Keras. You can use a Seaborn, which is the advanced version of Matplotlib because of the advanced functionalities. You can also experiment with NLTK if you are venturing into NLP. And you can also work with Augmenter, which I explained is data augmentation library. If you have progressed sufficiently enough and you want to move even further in your track of machine learning, then for advanced users, there are nice tools such as TensorBoard. So TensorBoard essentially augments the functionality of TensorFlow. So whatever work is done by TensorFlow, that you can nicely visualize using this concept of TensorBoard. Of course, this is developed by Google. You can also go ahead with Amazon machine learning tool. Actually, it provides a free trial for a limited period. So if you want to play with it, you can do that. But beyond 1 month, then you have to pay for use. And advanced users libraries, you can say TensorFlow you can use. So notice that I put a Keras library for intermediate and TensorFlow library for advanced users because so Keras is built on top of TensorFlow. So you can say that Keras is a higher level library and TensorFlow is a lower level library. So of course, the lower level you go, then more complicated the code becomes. So that is why I put TensorFlow for advanced users. You can also go for PyTorch. So that's an alternative to TensorFlow. And the last topic that I explained is the line, the model explanation, why an algorithm performs the way it performs. So you can move into the explanation part. And there's a lot of research happening in the explanation part, why the algorithm gives a particular output. And of course, you can use AutoKeras. I have not put AutoKeras for the beginner because, so let's say you use the AutoKeras code and you get the best result. But if somebody asks you why, how is this working? So there's a lot of concept called neural architecture search and a lot of detailed mathematical concepts required to understand how it chooses the best algorithm. So unless you're familiar with that, it's not advisable to use AutoKeras straight away. Okay, so this is my concluding slide. So I'll be happy to take questions, if any, at this point.
Yeah, sir. The first question that we have is between Spider IDE and Jupyter Notebook, which IDE is good for programming?
Yes. So Spider IDE is a nice IDE. It comes along with Anaconda. Uh, the thing with any IDE for that matter, not just Spider, you can use any IDE. For example, you can also use PyCharm or any other IDE. The problem with IDE is that you need to write your entire program. You need to compile it. If there are some errors in your program, then you need to troubleshoot it out. And then if there are no errors, only then you'll see the entire output. The advantage of using Jupyter Notebook and
Sir, I'm not able to contact him, so
Is
I
the
think
sound back?
hello. आ रहा है
Yeah,
क्या YouTube में? No ना?
I don't know.
Jovita?
Santosh sir, we are back live. We can continue with our question answer session.
Yeah, but is the audio clear now?
Yes, the audio is clear now.
Okay. Yeah, you can ask.
The question was, how does Julia compare to Erlang for DL?
Yeah, so I'll just repeat the answer. So I said that Julia is a recent language which has been developed since the last few years. So it would not be fair to compare Julia and R, because R is quite an established programming language developed over many years. Right. So, however, many people from industry are now moving towards Julia. This is unfortunate. So what should we do?
I guess we'll tell them that we'll reply to their questions on the chat itself.
How many more questions are there?
Um, we
I
have
guess on the
4 more
chat,
questions.
is not visible
It's
because.
back right now, so let's just take
Ah,
one more question.
okay, okay.
Which library is preferred for research, TensorFlow or PyTorch? Why?
I would prefer using a TensorFlow because there's lot of detailed documentation and lots of new functionalities getting updated by Google. And with TensorFlow also comes Keras, which is like a bonus. So if you are venturing into deep learning, my personal recommendation is would be TensorFlow because I personally use it a lot. PyTorch also has a similar concept of computational flow graph. But as far as the documentation and functionalities are concerned, then TensorFlow is a good choice.
The next question we have is, which tool is best for deep learning using medical image analysis like tumor detection and survival rate prediction?
Uh, uh, so actually for doing a project like this, it would be advisable to uh, write your own algorithm, right? So instead of using the standard algorithms which are available out there, it may not